Hi, my name is Piotr Wendykier. I'm a consultant at Wolfram Research.
Hi, I'm Cheren, and I'm a software engineer at Wolfram Research. This year, we'll be talking about new features in Mathematica and improved features in Mathematica in import-export. We'll also be talking about how you can add your own features to the Wolfram language to use with import and export.
We'll be talking about import-export today. So first, I will talk about the updates in these two functions in version 11. And then Sean will talk about the extensibility. What do we mean by that? Well, basically, we will show you how to develop your own converter, how to extend the framework to support your own format. All right, so quick overview, what's new and what's have been improved when it comes to import-export in version 11. How about that? So let me start from new functions. These are actually new functions, not new formats supported by import and export, but let me quickly explain what these are. Import byte array and export byte array. Very similar to import string and export string, but so you basically convert any Wolfram language expression to a file format. But instead of generating a file, we create a byte array for you, so stream of bytes. For import string, export string would generate a string. This function's export byte array generates byte array. As an example, we take the typesetted formula and then export it to PDF, and then we get a byte array. And once you have that byte array, you can get back your expression by calling import byte array. And it will basically give you the default representation for PDF. So that's a graphics object. Now this is newly introduced format. We did support PDF for a long time, but this is animated PNG. So basically, you can now export and import animations to a PNG format. The other nice feature is that you can directly export manipulate both to PNG and also to GIF and TIFF formats. There are nice features. You can, for example, specify how many times your animation could run through animation repetition functions, and there is also control appearance functions that you can control whether you want to export manipulate controls or not. Notice here, the manipulate controls are exported, and in this case, when you specify control appearance none, they are not. Another update about PNG, there is a compression level option that allows you to control the lossless compression built in the PNG encoding. And finally, there is a color map length option that allows you to generate palette color images. Again, this is the update both for GIF, TIFF, and PNG. So you can think about basically this color map length as a lossy compression. Obviously, you will lose a lot of information if you compress it to only 2, 4, or 8 colors. But the good thing about this, that when you look at this plot, this is number of colors versus file byte count. Obviously, you can save a lot of disk space if you don't care. If you, for example, want only 8 colors, then that's the way to do it. So we quantize these images behind the scenes, and that's what happens. Bioformats link. You might be familiar with the bioformats library, open source library written in Java. They do support more than 140 file formats that you basically can read the image data and the metadata using that library. So now we have something called bioformats link, which is a package that allows you to interact with bioformats library. Due to licensing restrictions, we cannot include it in Mathematica, but it is available on GitHub, and here is the link. What is it useful for? Well, basically, you can now import read images from formats that are not yet supported by import framework. And here is an example. There is a format called Nifty, and as you can see, import doesn't know how to import it, but now, using bioformat links, I'm extending the import framework, and now I can import that file. Because I don't have much time, I'm going to go quite quickly over the next few formats. So M4A, new format for storing digital audio. We do support both import and export of M4A files, but only on Windows and macOS. No support for Linux, at least yet. And here the elements of import. WMLF, Wolfram Machine Learning Format. Recently introduced to store new functions from machine learning, such as netgraph, classifier functions, and so on. Internally, it's actually using the HDF5 to store data. MXNet, this is the format used by the deep learning framework, MXNet. It actually uses two files. The JSON file is used to store topology, and the params file is used to store the data, numeric arrays. Here is an example. You can export the recurrent net to specify basically the JSON file and the MXNet as a format. And then we can nicely visualize it using that node graph plot element of import. You can visualize what happens inside that recurrent network. UBJSON, another new format. That's the format to efficiently store and retrieve structured data, JSON-like data. So given such results from various sensors as a Mathematica association, we can export that to UBJSON, and comparing the file size that has been created and the byte count of the object, you see that this is efficiently stored in a file. Next, GeoJSON. That's basically open standard for representing geographical features, simple geographical features. It's useful for exporting geographics objects. Okay, so simple geographic objects with a geomarker of Champagne City. We can export that to GeoJSON, and that's how the data are stored. So this is the import of the data element. And obviously, that's the format that you can then import in other packages than Mathematica. Three formats that have a lot in common. Basically, these are configuration file formats where you store the string associations, key to values, and they are stored as plain text. So an example, again, association, key string values is stored as an ini file in that way. Then the PHP map association of all foreign language association converted to PHP map using PHP ini format. Let me maybe quickly skip that. I want to talk about the updates in the formats, image raster format. So GIF, nice speed improvement in version 11, both single frame and multi-frame GIF. We do have some new import elements as well for GIF. A big improvement in HDF5 format. nice. This is a hierarchical format, so we can now nicely visualize it using the structure graph element, and here we also have a structure graph legend. New data types are now supported. We support byte array, which corresponds to HDF5 opaque type, array enum, compound, and complex types. You can get it through data format element. Data encodings, 3 data encodings are supported now. This is very nice feature. Take elements option allow you to import the data efficiently. You can basically access partial data from HDF5 using that syntax. And again, a nice performance improvement. Fits. We're still working on that. You see, this is prototype build, but a lot to come. A lot of new nice features in fits as well. Performance improvement is quite significant. And finally, the last 2 formats I want to mention is CSV, comma separated values, and TSV. They have been updated recently. Now you can export directly data sets, time series, quantity arrays to both of these formats. We have a number of new import elements. You can directly import data sets as well. New import options, fill rows, skip lines, allow you to control how you want to actually, for example, deal with comments in such files. Definitely overall stability improvement in the format, and as usual, the performance improvement. All right, so that was quick overview of what's new and what's improved. Now, Sean will explain you how to develop your own converter.
I've been endearingly referring to this part of the talk as developing your own import-export converter, so I don't have to. And we understand that at Wolfram Research, we want to make our technology as expansive as possible and integrate with as many technologies as possible. But for whatever reason, maybe we don't support the format yet, or there's a lesser known format, or you have some proprietary data format inside your company that you want to use, or you want to extend one of our existing formats. For these reasons, you might want to add code to import and export. So you can see that we have many, many formats that we already support, but there'll never be a stop for the demand of new formats. So to start, let's look at this tutorial. So I don't want to go over too much information that you can find in a tutorial very easily. We have this notebook available, and we posted it on the slide for this talk on the website, so you can go and get these slides and see all those additional features that we didn't get to show before. You can also get all the direct links from here. Don't worry about writing these down because the last slide collects all of our reference links. So in this directory, installation directory, system files, formats, format, you can actually see the registrations for our formats. For these formats, you can actually see the entire source code in the converter.m file that's located in that directory. Import.m is where we hold the registration, and export.m is where we hold for import, and then export.m is the registration for export. So register import is the function that you call in the import-export context to add a function to import. The format is the first argument. Then you have a list of rules where the left-hand side is the element name, and the right-hand side is the function that gets called. So let's go back and actually take a look at a simple example of registering a format called WTC. So for WTC, so the first thing that we want to look at is this elements element. How do you tell import when I say import of this file elements, what elements are available? Well, there's 2 ways this could happen. The strings on the left-hand side of the rules it will look at those left-hand side strings and automatically return those. But as you can see, this first element has this pattern where it could be one of 2 different things. It won't recognize these. And for that reason, I suggest that you always define this function called getElements and list in one place what your element names are. So on the left-hand side, we have the element name, and then that goes to an actual function that implements the converter for you. So you'll notice throughout the talk that I have these little wolf symbols. These are tips and tricks for what we do inside Wolfram Research and how I suggest that you build your formats. So the import functions that actually get called by these might look like this. The first thing that you'll notice is there's always this pattern of the file name and then any options that get passed to the converter. Now, up here, you'll also notice that there's this function over here that doesn't have a name on the left. Now, this is what will always get called if you want to send something to a post converter. So you'll notice that there's this list of elements here, which will return basically some kind of raw data. But then you might have other elements which all basically build upon one element, and that's this default element at the end that will get passed to any of these post importers. You'll also notice that there's a default element option. What this does is tell it when I call import of just a file, this is the element that it should call. Whereas this is the default element that gets passed to any of these post importers. Now these can be different, and I'll show you an example of that. So if we actually run this, there we go. Now we can actually call import string of WTC. Now you'll see that the default element is going to summary, which basically just gives you a file byte count. And you can see that these are the same right here. For data, it's basic, and now you'll notice that this function here, we can pass the element name in, and it needs to know, so one function could handle two elements, but then you need to tell it which element it's currently processing. The other important tip here is that you always return a rule from these functions which are which are implementing your converters. Now, raw data is basically just those raw bytes, and as you can see, raw data, which is that default element that gets passed to post importers, gives the information to grid, which then wraps a styled grid around it. Export is much more straightforward. Because with import, you have all these elements that you're going to. With export, you just have all these data types that you need to recognize and then go down to one specific format. So export, you might define multiple definitions, which basically normalize your data in some way that is recognizable by the function that writes to the file. So in this case, we always want to have a list of lists. So we might say that for a sparse array, you would call normal before passing it to that. There are a few registration options which are a bit more advanced, and this is where you can really fine-tune the functionality of your converter. So sources is pretty straightforward still. It just tells it where it's going to find the source to actually implement the code. So if your code uses JLink, you need to define it here. You can specify the context that all your functions are going to come from, and it will also look in that directory that I pointed you to in the tutorial to look for the source in there. And a function that we use internally is default sources, which will basically find the file path of those things. If there's one thing that you take away today, it's the function channels option is the most important thing that you use when registering an import function or export. If you do function channels file names, then you're going to see that pattern that we saw above where the first argument is a file name. But it is much more efficient if you have a way to recognize passing a stream directly to import. If possible, always, always, always implement a stream function rather than a file name function. The only reason you should implement a file name function is if your library that you're using explicitly takes a file name rather than some data. And you'll notice here that basically the main difference is that this gets passed an input stream. Binary format is the last important option. It will determine the type of stream that is passed to your converter. So if you look at input stream or output stream, they both have this option called binary. And if binary is true, then you're going to be using functions like binary read, binary write, and that is the main difference here. However, there's another important feature for export. When you're writing bytes of data to a file and it has a particular encoding, typically you would have to handle that in your converter. But the framework handles this for you if you set the binary format option. Then, when it opens the stream that it passes to your converter, it will open it with the character encoding option. So all you do is write characters. You can write the string, and it will automatically encode those bytes correctly. And this is one of the reasons these types of tools are why we basically do this. You could just write your own converter functions and call them yourself, but then you're going to lose out on all the functionality that you get when you integrate with the framework. So next we're going to talk about development tools that you could use. And I have to gloss over this quickly, but basically, Library Link and Math Link or WSTP are definitely going to be the way that you can do the fastest I/O for getting data back into Mathematica. I highly, highly, highly recommend you go to this talk, Library Link, High Performance I/O Tips and Tricks, where Rafael will talk about how to use new utilities to build better Library Link functions. We mentioned that there's Bioformats link on GitHub. With this, you can actually go and look at our registration there and see an entire converter that we built in-house rather recently. Now, obviously, the point of all of this is so that you can bring your data in and actually do processing with Wolfram language. So what you can do is actually, when we invent a converter, we just want to give you the raw data so that you can play with it yourself and use your own advanced functionality. When you're developing a converter, you have the option of making it as rich and expansive as you want right out of the box. This last slide is basically a collection of these important links that will get you on the right track for developing your own converter. Thank you. We have a few minutes for questions. Sure.
Are there any plans to support new channels, like for example, these new light arrays or things like that?
Absolutely, that is definitely on our radar. Any more? Okay.
Is there an easy way to import large hierarchical data sets, not the entire data sets, but if you know the keys, for example, without import just the parameter?
Yeah, I did mention about that maybe very quickly, but yes, import of HDF5 is, unless you're referring to a different format, but yes, HDF, hierarchical data format, there is a very efficient way to import partial data from.
And we're expanding that to support for more formats.
You mentioned that we could view the source code for a couple of them. Were there, out of those like 5 or 6 that were there, or any of them particularly would you recommend if we wanted to see a larger example of what
I would recommend using those to get the structure for how to build your converter, not necessarily the best practices for building them. But those formats are kind of lesser used and they're very small formats, so you're not going to see a whole lot going on in there anyway. The best thing to look at would be Bioformats link, as well as the examples that you'll see. And I guess we forgot to mention, you should really be paying attention to this GitHub page, because what we're encouraging here is that as we build these converters, these are things that we can package and actually distribute. So this Bioformats link that we have on GitHub, now people can download and use that. So now we actually have a mechanism for sharing converters and building import-export together, and not just using the tools that are out of the box.
Well,
we actually don't work on semantic import.
Right. There is another team working on semantic import. I mean, we can definitely get you in touch with those people.
I'm just trying to understand if this is the direction that basically is still viable, or is it kind of like a dead-end street, because it doesn't seem to be working with the large files and seems to be
right, but
so,
yeah.
I mean, we are also making updates. There are definitely plans for making semantic import and import more coupled together so that they're using kind of the same backends. So when we add stability and performance improvements down the road, you'll start to see those appearing more and more in semantic import.
So have you also touched the Excel spreadsheets, because XLSX and problematic?
I can say that I know somebody is working very, very hard on Excel, and it's me.
Any chance you're also working on export to Google Sheets to the authentication layer? Like exporting formatted data right into a right Google Sheets?
So basically, then you're looking at the connection technologies. I wonder if you actually tried using some of the options that we have for URL functions with import. It might just kind of work. But we can talk about that more later if you want. Got time for one more, if there is one. Great, and we'll definitely be around here. So if you find me, I'd be happy to talk with you more about what we'll be bringing to the table and help take a look at some of the things that you're using import and export for. We're very interested in how you're using this technology, and that'll definitely influence what we're doing in-house.